So again, looking at the behavior by the asymptote, and the generalization here would be, if we do have an asymptote, we've never seen really anything other than either infinity or negative infinity. Okay, so from the left or from the right, okay, the answer is either going to be one or the other. Okay, so really any asymptote that we've discovered so far. Okay, all right. Now let's move on to this other point, this -3 point right here. And you'll notice that it's not an asymptote at this point, but there's some kind of break going on here, if you will. And so when we look at a limit at a point, okay, and we'll start with, I'm going to start with the 0 point, if you will, and then we'll go back to the -3 in a minute. Okay, if we look at 0 itself, here's x equals 0. Okay, notice the question is the limit of f of x as x approaches 0. And here's our 0 point. If we look at what we're getting close to at 0, another for the y values from the left and the right. Okay, so look at it from the left first. As we approach 0 from the left, what y value are we getting closer to? Yeah, we're getting closer to the origin. That's the y value of 0 also. As we approach from the right, what are we getting closer to? 0 also. Okay, and so therefore the limit at that particular point is 0. And again, another generalization, if we have just a normal point, okay, is the limit going to have the same value as the y value at that point? Yes. Okay, yes. However, when we look at -3, for instance, from the left again here in my notation, if I go from the left, okay, what are the y values getting close to here from the left? They're getting close to the y value of -1. So I can answer that question. That question's answer is -1 because the y values from the left are getting closer to -1. Now, I'm going to look at this column here. All right, and what I want you to see here next is the limit as we approach -3 from the right. And if we go to the right of that -3 point and we make our way down towards -3 in the x direction, what are the y coordinates like? It's getting closer and closer to -3. Now you'll notice it's an open circle, so does it actually get to -3? No, but based on our end behavior analysis, we don't have to actually get to -3 to have the limit be -3, do we? Just like we did with 0 a minute ago. So therefore the answer to this question is in fact -3. All right. Now, one final question about that -3 is there an answer to this question? Okay. We can see that there is a left-hand limit. We said that's -1. There's a right-hand limit. That's -3. And so the question is there a limit at -3? Okay, and the answer is no, there's not. Okay. Because in order to have a limit at a point, what has to be the case is the left-hand limit and the right-hand limit have to be equal. Okay. So based on our analysis here, we have two different answers for the left and right-hand limits. So therefore, the limit at that particular point does not exist. There is no limit at that point. Okay. And looking back at our 0 point, okay, you'll notice that the left-hand limit and the right-hand limit, as we discussed earlier, were both 0. And if they are equal to each other, then what is the limit at that point? It's that same number. Okay. So just at quick glance, besides that -3 point, does it look like there's any other points that would have no limit or have the limit b does not exist? Remember, keep in mind what we said about limits is that at the particular point, whatever point in question, okay, the left and right hand branches have to come to the same point. Okay, do they have to actually get to the same point? Not necessarily, but they have to approach the same point. So besides this point right here, it looks like everything else, well, of course, besides the asymptote, okay, but everything beyond that, okay, it looks like whatever point we pick, even these points that have holes, okay, don't the left and right hand branches go to the same spot, even though they don't actually get to the spot? Yeah. All right, questions so far? Saw one hand still. Oh, good. Okay, what I want to look at then next is, should I take that off? I want to use both of these. All right, let's look at this 2 point. We have x equals 2 here. Let's do an analysis on this and see what we'll come up with for the limits here. And again, my art's not that great. We'll say that that's 2 also. Okay. So 2 from the left, I said the answer is 1. Okay, because as I go from the left towards the point x equals to where x equals 2, my y-coordinate is approaching 1. True? And if I go 2 from the right, my y-coordinate is approaching 1 also. So therefore, is there an answer to this question where there's no plus or minus on it? Yes. As long as these two are equal, then there is a limit at that point, and it's the same number. Okay? And again, that's the part where you got to open your mind a little bit, because you might think, well, there's a hole there. How can there be a limit? Okay? Well, remember, just like we did with end behavior, do we actually have to get to the point to say there's a limit? Okay? As long as they're approaching the same point, okay, there is a limit there. Similarly, if we look at the 9 point, the point out to the far right, the limit is -1 here, because as we approach 9, the y-coordinates are getting close to the y value of -1. Okay. As we approach from the right, they're also getting close to -1. So therefore, the answer to the question, is there a limit at -9? The answer is yes. And what is the answer? It's -1. Okay. So even though there's a hole here, and actually a point defined up here, okay, is the curve approaching this point? No, it's approaching this right here. It's approaching the hole. So we still say that the limit is -1 here. Now there's going to be a little bit more that we're going to discuss with this later when we deal with what we call continuity. But for now, all we're concerned about is limits. Okay.